eventually share. I mean, send by mail.
I will send you the link on the mail if possible.
No, I think that's. No, it's not. My background's not working, unfortunately. Can you put background, some background on me? I mean, by phone, I wonder if it is possible. Because mine is not working. Nope.
I will try. Probably it allows only for applications. I shared the course link on your Outlook mail ID.
Okay. No, my background is not changing. Strange. Even blur is not working. That's okay. I'll some other time try. So this is all offline course. Oh, sorry, online course.
Yes, ma'am.
So you don't have offline. You don't call them to get to Skywatch or something like this.
No.
By the way, I have a fun quiz. Actually, I wonder if I can share my. I don't have even possibility.
Okay, I will share the
screen.
permissions.
I can't share my screen. No, not allowed. Yeah.
Just a minute.
Yes, only meeting organizers can share. Because I have a fun quiz, which we usually always run in our open days, and all people, kids also love it.
Okay, I will allow.
Try to do that. Shall I log out and log in again? Maybe that will work. Or shall I send it to you by mail? Because
okay.
you can.
I will just allow you in a minute.
Oh yes, please try. Let's try. Anyway, it should be helpful.
Now you will be able to share the screen.
Oh yes, I can see that. So shall I try now? Shall I share and we'll see how it goes. Okay, entire screen, share. Okay, can you see it?
Yeah.
Can you see my screen? Okay. doesn't work. This will work. Yeah. Can you see?
Yes, ma'am.
Okay, good. So something like this. It's fun, and it is just calling for MCQ. Like for example, this begin like. Would you like me to run it?
Okay, ma'am. Even participants can participate in it.
Yes. That would be great. Okay, so I stop sharing for now. But then, when you tell me, I will do it. Actually, it's quite fun, and it shows that you know more about space than you think. Oh, sometimes some simple answers turn out to be complicated ones. So you're muted.
Yes, ma'am. We can start. Yeah.
Okay. So then you please introduce me. Then.
Yes. So good evening, everyone. Our speaker today has one of the most fascinating career journeys in astronomy. Uh, she didn't start out as an astronomer at all. Dr. Margareta Safonova began her academic life in chemistry of rare and radioactive elements in Russia, and then moved into theoretical physics and eventually found her way into astrophysics, earning her PhD from University of Delhi. Her career has taken her from Russia to Cambridge and then finally to Indian Institute of Astrophysics in Bangalore, where she spent 18 years as a researcher from 2006 to 2024. Since 2021, she has also been visiting faculty at MP Birla Institute of Fundamental Research. A very warm welcome to Dr. Margita. Thank you so much for joining us today for Careers in Astronomy, a session that is part of Astronomy 101 course. As Deep mentioned, for those who don't know, Astronomy 101 is our introductory course, which is basically designed for those who want to get started with astronomy, basics of how stars, galaxies are formed. And also we have another things apart from the theoretical module, we have the computational and the observational module. Currently, the 2 weeks of the course has finished. Today marks the start of the third week of the course. And this session is specifically to discuss about what a career in astronomy look like, the choices, the challenges, and how you can start your journey in the field of astronomy.
Oh, okay. Yeah. So okay. So I actually, as a beginning, like in a warm up, I have a small presentation, actually quiz, which I would like to run, and it is just simple MCQ. And once you please say the answer, it will be like a letter. Okay. So you may figure out that you know more about space than you think, and it's just fun. Okay. So let's start simple. Somebody say, can they speak?
Yes, ma'am.
They're allowed.
Space and everything in it, including.
Yeah, that was easy. Okay. What about next?
The star nearest to us.
Correct. A lot of people say B for some reason. Okay.
C in 8 minutes.
Yeah, because of finite speed of light, of course.
C.
See, that is a common misconception. What is the correct one? A light year is actually a distance. Yes, it's a distance measure, not the time. It's a distance measure. Okay.
Earth.
Correct. Earth is a planet. Planets are astronomical objects. Very good.
D.
D. Yes. Okay.
C.
Very agree. C.
Yeah. From which country?
Russia.
Yep.
Russia.
Yeah. This is a tricky question. But if you think how much stuff is out there, actually, in space, in our solar system, you can answer correctly.
D.
D, exactly. This much meteorites, meteoroids, rather we call meteoroids, fall on our planet daily. Yeah. Okay.
A.
B.
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 We don't see
don't
it from
see.
the
Wait,
Earth.
of course. Yes, yes.
D.
Okay.
C.
C. Correct. D.
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 Very good.
C.
B. On which planet?
B.
Mars. Mars.
Then Mars.
Yes, yes. B. Which one?
B.
D. D. Oh, oh, maybe all of this. Exactly. All of it. E.
It is B.
All of this.
Ma'am, it will be, I think, B.
Yes, correct. Galaxy doesn't belong to our family. A star is, our sun is a star.
D.
And the last funny one.
C.
C.
A.
Yeah, of course, that was fun. And obviously, astronomy is.
B.
Mm-hmm.
B.
B.
Yeah. So, and this is fun. That is why we are doing it. Yes.
Oh, yes, sir. So,
Very
like,
good. Very
now,
good.
yes, sir. And now, like, let's start with just some friendly questions. So, like, your academic journey starting in chemistry, moved to fundamental physics, and ultimately to astrophysics. So it is actually fascinating because it mirrors how the universe itself operates. While we often learn these subjects in completely separate academic silos, the cosmos obviously doesn't separate its chemistry from its physics. So, like, how interconnected are these fields to astronomy, and how expertise on all three fields helped you in your research?
So yeah, that is very interesting. I actually wanted to be an astronaut since my childhood, cosmonaut in those days, because of Yuri Gagarin and all. But then by the time I came to like middle school, I got glasses, and with -5 or something, you can't become astronaut. So then for some reason, I fell in love with biology. So I decided I will be biologist. I will be gerontologist. I will extend life. And so on. So I started working in that, but then Soviet Union collapsed. So my first MSc was chemical chemistry and chemical biology, actually. So biochemistry. Soviet Union collapsed, and theoretical physics was the only theoretical science was the only one who was which was actually possible to do, because no labs were working. We couldn't get any reagents. We couldn't get any things, and so that's why I thought that I will go and do theoretical physics on a pen and paper. So that was my second MSc in Sternberg Astronomical Institute, and because I met astronomers there, so during that first year, I suddenly fell in love again with science, with space and all, and I thought, oh no, I should do astronomy. So that is it was a theoretical. And then I came to India to do my PhD. And when I finished my PhD, it also was purely theoretical, in gravitational lensing, wormholes, and GR. So, but then I joined IA, Indian Institute of Astrophysics, and we had the School of Statistics, Astrostatistics School in our observatory in VBO, Vainu-Bapu Observatory. So when I saw the telescope with my own eyes, I thought, wow, I should invent something so that I will observe. So I fell in love totally with observations. And that's how combined my ideas on gravitational lensing, observations, and that's what I continue doing this. And of course, the old love for biology never went away. And so astrobiology kicked back. So astrobiology is actually exactly what, what I want to say to everyone, to students also. We know quite a lot about the universe already. We know its origin, we understand its origin, we understand how it is evolving, and we understand in some sense how it may end, depending on, we just don't have enough information yet. But there are physics laws are same, but there is fundamental question in astronomy. What is life? Nobody can answer, nobody can define life even yet. There are some 500 definitions of life exist. Nobody can define life, and we can't understand how life originated, what is life, and why life. So that's why this is the most fundamental question now in astronomy. That is why astrobiology is a merge of biology and astronomy, or astrophysics rather, because of course our body consists of, there is what we call SNOPs, CNOPHS, those elements from which basic elements for life. And all those basic elements for life were made very first stars. So it means that chemistry in the universe is the same. Throughout all our universe that we understand, chemistry is the same. That's why we understand stars. That's why we understand planets and development of the universe, its evolution. But where is life? Why there is life only on one tiny planet when we know that trillions of planets actually exist? So that is now a most fundamental and most interesting subject, which I am also trying to work on, which is astrobiology.
So yes, ma'am, like as you said, the India has a rich heritage in observational astrophysics and space engineering. But what is the current state and moment of astrobiology within the Indian scientific community, and like what are the future challenges that we are looking forward to solve?
Oh, now astrobiology actually quite picking up quite a lot in India. For example, in July, I am going for astrobiological expedition in Ladakh, which is organized by Amity University. Amity University now has huge astrobiology center of excellence. Even PRL, working in PRL, there are people who work on astrobiology in IA. I work on astrobiology to some extent and a little bit theoretical, but in this expedition will be for specifically in Ladakh, because Ladakh is an early analog of early Mars. Current Ladakh is analog of early Mars, when Mars was still habitable. So we will be collecting samples for so-called extremophiles from hot springs, from salt lakes. So those are microorganisms that can survive in extreme environments. And by extension, it means that they can live on other planets, or at least in our solar system. And as I've written in one of my books, our solar system is already contaminated by life. For the last 4.5 billion years, there was life on Earth. And since then, there were enormous amount of meteorite, asteroid, and comet impacts, throwing tons of material into space. And each gram of water, and each milliliter of water, and each gram of soil on Earth contains millions of bacteria and viruses, millions of microorganisms. And all of them now spread around the solar system. Even if life on Earth was not the first, life on Earth already contaminated all the terrestrial. If we find anything on Mars, it will be ours, for sure. Because we have meteorites from Mars. Mars also has meteorites from Earth. So, yeah, so that is what I mean. But astrobiology in India is quite a very well developing place, science now. And there are several places in India which work specifically for it, yes.
Okay. My next question would be like, you have seen the scientific and research culture across 4 very different countries. So, like, what is something unique that is in India or that is in any other country that you observed for astronomical research?
Well, that is a difficult question. Yes, difficult question. Let's say in India you have more freedom to do a lot of things. To do, in science, what is happening that you start very specialized. You finish your PhD in very specific topic. You write some papers. Then you go for your postdoc. In postdoc, you're exposed to other subjects. You get interested in other subjects. Then you go for second postdoc. Then you join some lab or some institute which doing something else. So in principle, just like me, you can work in several different topics, several different subjects within astrophysics or astrobiology or whatever field you choose. It can be radio astronomy, it can be X-ray and optical and so on. So in India, it is, for some reason, there is more freedom to work on many different things. But that's what I noticed. That is good. At least your guides or your like senior colleagues kind of they do the same thing themselves. I think it is, in America, it's more restrictive. In England, I've been in England, I stayed in England, I was working there also. It is more kind of rigid, yes. And the same thing in Russia. In Russia, it is a bit easier, yes. But in India, there is more freedom, yes, to do many things at the same time. But after you finished your PhD, and you already, maybe during your PhD also, it depends on your PI, your professor, of course. But even in our group, for example, our students, in our group, SPG group, small payload group in IA, our students work on several different instruments. One instrument will be with them, for sure. They have to build it. This will topic of their PhD. But they participate in other instruments, in making, in calibration of other instruments, in science of, like, for example, near ultraviolet, far ultraviolet, and so on. So it's also kind of outside. Or balloon program, that what we are doing. They participate in that atmospheric some parts of atmospheric science. Yeah, so in India, it is in that sense, it is good. That's what I noticed.
Always research doesn't go as planned. Missions get delayed and projects get cancelled. So, like, has there been a moment like that in your career, and how did you deal with it?
Yeah, that happens. That has happened precisely when I joined IA, Indian Institute of Astrophysics, specific project which was called TAUVEX. That was Israeli-made telescope, which was ISRO supposed to have launched to geostationary orbit, and we were theoreticians. We were working in ultraviolet astronomy. So that telescope had all the filters. It was from visible to just like nearly AstroSat. There were 3 telescopes together, maybe better than AstroSat, but smaller in the sense that no X-ray. So, and unfortunately, yeah, we did a lot of work on it my first 2 years. But unfortunately, at the last moment, launch, ISRO canceled our telescope. They said, you're too heavy. It was 65 kilograms too heavy. And on one hand, it is good because that particular launch went down into the sea, went out into the sea. So the telescope survived, but in the museum. Yes, that happened. But while working on it for 2 or 3 years, of course, you learn a lot of other things. And that is why we continue building the small payloads in ultraviolet, because for UV, you have to go outside the ozone layer. So, and our balloon program, we developed specifically to test those small payloads, to test them. Because if you send them to the low Earth orbit or whatever orbit, that's it, one way. No return, no correction. If you launch a balloon, you can test and you get it back, you can correct and send it again. So that's why we developed our balloon program. So in that sense, yes. And of course, as I said, my love for biology came back, and I'm working a little bit on astrobiology to some extent, and so on. It happens, but that doesn't mean that your work is wasted. No, because while working on the project, even if it is cancelled, you still learn a lot. And you can apply that later to other subjects, to other applications.
Like I agree on this point. So I want to ask next question. Like for students who are discovering an interest in astronomy today, what are the foundational subject or skills that you would recommend they should focus on early?
Okay, of course, the most important part is basics of physics and mathematics. Mathematics, of course, is most important, and these days, statistics. Without statistics, even biology is not possible now. You have to be very good in statistical analysis. You have to analyze lots of things. You have to be good in statistics, programming, of course, whichever language you choose. Now these days is Python, but Python is not a final solution to everything, because some codes in Python still do not run. For example, my student was working for the same thing that he was asking about making RGB color photographs, color images of comets. For now, still DS9 and IRAF are still the best. Python didn't work. So my student complained to me that she uses Python and she couldn't do it. So, but several languages, programming languages are important. But of course, as a base, physics and mathematics. That is the most important.
Yes, that's why I'm even in our course Astronomy 101, we have a separate computational module in which we teach Python, basic ML and statistics.
Yes. That is very important. That is very important in physics, in astronomy. I mean, theoretical physics, even they need, yes, of course. But as I said, even in biology, statistics is now important.
Also, there are some people who are not from pure physics background. So how interdisciplinary is like astronomy seems to pull from physics, chemistry, biology, and now even computer science at all, as you mentioned. So if anyone is not from the pure physics background, is there is room for these people or these students who don't like even us, we are not from pure physics background, so how we can get into astronomy?
Yeah, because as you know, what I usually say that astronomy is a unique science. Astronomy, because it incorporates in itself all other sciences. Like you must have heard about astrochemistry, astrobiology, astrochemistry. Like astronomy, chemistry we know very well, but only astronomy can tell you where the elements came from. So here you merge the understanding of elements and the understanding of physics. Yeah, in astrochemistry, we understand what are the elements and where they come from. And they come from stars. And the first few elements come from the Big Bang. So that is what astrochemistry in that sense merges physics and chemistry. Or astrobiology, as I said, that to understand the origin of life, we have to understand the other environments. Like, for example, what is the environment on Mars right now? And earlier, what is the early environment on Mars? And what is the extent of biosphere, or our biosphere? To understand the extent of biosphere, you have to understand biology to some extent, because we know that life exists down to nearly 10 kilometers into the ocean. There is life. And life extends up to nearly stratosphere. In clouds, definitely are full with bacteria. Actually, rains, microorganisms sometimes even work as seeds for rains in the clouds. So that is why biology, in that sense, astrobiology merges physics and biology. And anyway, biology is physics. Chemistry is physics, isn't it? There was a very funny meme, so to say, picture. There is a reason for everything, and that reason is usually physics. Because it's elementary particles, we are all made from elementary particles, and science of elementary particles is physics. So in that sense, whether you're doing chemistry, whether you're doing biology, if you want to work in astronomy also, you have to understand physics. At least basics of physics, yes.
So like basics of physics is like the must to get into astronomy, and after that you can, if you're interested in biology, you can go with astrobiology. If you're interested in chemistry.
Yes. And as I said again, astronomy, you can be engineer and still work in astronomy by making rockets, understanding why rockets work. How do they work? Whether there is a better version of what is the way to launch from the planet? What are the ways to launch from the planet to space? How do you fly in space? So this is understanding of engineering, of rocket propulsion and so on. This is a merging of physics and engineering. So as I said, astronomy in that sense is unique science. It incorporates all other sciences within itself. There is even astroarchaeology now to explain what are Jantar Mantars and Stonehenge and so on. There is even astroarchaeology.
So like if anyone want to go into the field of astronomy, what advice would you give to students? Like it's not a conventional path to go into astronomy. If you see doctor engineering, that is a very conventional career path to go in. But astronomy is not as such a very conventional path. So what advice do you want to give to the students if they are thinking of going into this domain?
See, what going into astronomy means by working professionally in astronomy for the rest of your life. For this, of course, you need master's degree and PhD. In that sense, you need to do this if you want to do science. If you want to do engineering, PhD may not be necessary, but master's is necessary, of course. Master's is still necessary. So in that sense, if you want to do astronomy as science, then you have to do PhD. And for this, your MSc, I had a student who's actually who first went for second MSc. He did his first MSc, not in Christ, I forgot where, it's in Chennai somewhere. And then he worked with me, we wrote a paper. He's a very good student. And then he said, no, I want to work in gravitational astronomy, gravitational waves and all. So he joined the second MSc to specifically work on gravitational waves. And hopefully he will go for PhD also. So in that sense, 2 MSCs is not a problem. You can have 2 MSCs. If your current MSc is too far from, let's say, astronomy, so that you can, in India, in that sense, of course, there is a slight, if you have your MSc in biology, you can't immediately go for PhD in astronomy, yes? That is not possible. So, but if you really want to do it, go for second MSc. But MSc in physics and astrophysics is important, because that's where you get the basics of physics. And after that, you can join any PhD, whatever you want, in whatever subject.
Okay, or also if we are currently in college, so what kind of internship or summer programs or reaching out to professors, what steps we can do? So even at this initial stage of doing our bachelor's, we can get some taste of research, and we can after that we can proceed with masters in astronomy and astrophysics.
Yes, yeah. I don't know about other institutes, but our institute has specific internship program. You can go on the website and you can check. Indian Institute of Astrophysics has specific internship program where special bachelors can join. They even, some of them even pay the stipend, and they can do projects, and then they can continue with MSc in astronomy, astrophysics, and whatever they choose, because now MSc is given in, at least in Bangalore, in that sense. We have all the semi-private universities, Indian Institute of Science, of course, Indian Institute of Astrophysics, Raman Research Institute. Then there is a Jain University, St. Joseph's University, and Christ University. All of them from Bangalore University. Bangalore University, Central University is not very good. That I want to say. They have very bad astrophysics program. They have hardly any physics actually. BCU. So don't do BCU. But Christ, St. Joseph's, Jain University. Now it is Amrita University. They say is very. By the way, I went to give lectures in Amrita University in Tamil Nadu. That was they have huge department. They were very interested, the students, and of course Raman Research Institute, ISRO is there in Bangalore, IIC and IA. In Bangalore, in that sense, we're lucky. We're blessed.
Yes, like Bangalore is the hub of for the, all the Islamic colleges.
Yeah, it seems so. Now it seems so. Of course, in Pune also there's a good places, Ayuka, of course.
Yeah.
And now there are some other private universities also in Pune coming up with this. But they're all affiliated with Ayuka, actually.
Okay, so now if anyone from the audience want to ask some question, they can ask.
Oh, high school students. Okay, so in IA we have some program which is called Shadow the Scientist. Just recently, my office mate had a girl who was very interested in everything. I was even taking her around. She was from, I think, 9th or 10th grade. So we have a program called Shadow the Scientist. So in that sense, students, and I've written one book on comets. My co-author was actually at that time 11th grade student. Now he is finishing MIT. Yes, of course, internship in possible, absolutely. Right now I am in Birla Institute of Fundamental Research. We run special summer program for for students, for school students, and 100 hours astronomy and astrophysics course for bachelor students, for anyone who has B+. I mean, bachelor and higher. So you go to website of Indian Institute of Astrophysics, check Shadow the Scientist, that is for school students, and go to website of MP Birla Institute of Fundamental Research, Bangalore, and there you can see the 100 hours course on astronomy astrophysics. We run usually starting from August, every Saturday. And summer school, this is just finished, summer school for school students. This is usually April and May. I don't know about RRI. RRI, I don't think so. They have some telescope making workshop recently I saw for school students. They had, yes. It's not exactly internships, but workshops they do run. IIC, I'm not so sure. But our institute and RRI runs these telescope making workshops. Well, wait. There are several questions. Let me see. Yes, women do face difficulties. That is, it's getting better actually. It's getting slowly better, but there are still difficulties, yes. Especially in, let's say, theoretical physics. Though, as I said, it's getting better. As I noticed, at least in India, every year it is slightly better every time. Yes. Like, for example, today, there's a woman professor who started running the course on special and general relativity in IA. And let's say 10 years ago, I wouldn't have imagined that. Now it is possible, yes. Now, exactly, that question about life forms. That is the problem. So, but what we can, the problem actually comes not just from the that we know what our life consists of. Yeah, we know our life is based on let's say amino acid and sugars. Amino acids are left-handed, sugars are right-handed. Yeah, so we don't know why it is so, but we know it is so. If we find on Mars something that is not like that, then we can start thinking. But there is very interesting topic which was developed roughly in the end of 80s, which is called shadow biosphere. It is quite possible that you can Google it later in Google shadow biosphere. The problem is that what we know life on Earth is because we understand it. We know how to look for it and we know where to look for it. But it is possible that there is life on Earth which is not based on this exact components or exact ingredients that we know. So we just don't know how to look for it. That is why when we find something on Mars, it's quite possible that we have it on Earth, but we don't know. So it's very complicated question, especially that chemistry throughout the universe is the same. Amino acids were found even on asteroids. You must have heard about this latest news about on asteroid Rigu and Ben. What was that name of that asteroid? Several amino acids were found there. But those amino acids were both right-handed and left-handed. They were no specific. Our life uses only left-handed amino acids. So that might be one of the clues to that why that could be only native to Mars and not contamination from Earth. Okay. Next question about what extracurriculars can we build in grade 12 so they can research institute abroad for BSc in physics. Extracurriculars. That is difficult for me to say, but if you can always study more astronomy, because unfortunately in India has one disadvantage. There is no astronomy as a subject in schools. This we talk about it for years. In my daughter's school, the owner of the school actually asked me to write the textbook for astronomy. And I did. I did textbook on astronomy for 6th grade. But he was so crazy about astronomy, he wanted me to put quantum gravity in it. Imagine, 6th grade. I said, they don't know yet about gravity. Want me to put quantum gravity. So I made the basic textbook, yes, for the 6th grade. And after that, they only in 6th, 7th grade, they could do their own textbook. After that, they gave up. So that is the big problem. That extracurriculars, astronomy is extracurricular activity. Astronomy, you can buy telescope. These days, you can buy your own telescope and do amateur astronomy. There is a lot of amateur astronomy or what is called citizen science. Like in the same MP Bill Institute of Fundamental Research, we run a course. I read that course, which is called citizen science. So just on this summer school, I gave a lecture 2.5 hours lecture about citizen science. So even students can do astronomy now by using internet resources. Because there is so much data, there's actually so much data now, so many astronomical data, and so few astronomers that even NASA, even ESA, they all ask people to come use our images, do astronomy, do citizen science. And even in India, it is even radio astronomy. And you can be even in the paper. They publish the papers with amateur astronomers in it, with citizen scientists, because you produce data. So yes, it is possible. Okay. So next, especially after continuous astromining, yeah, exactly. How to differentiate native from mutation? Well, mutations may be easier. We have constant mutations here on Earth. Mutations are all the time. The problem is to how to recognize something that is alive if it is not exactly behaves like what we used to. There was a paper. Actually, I just want to share it. So I'm working on cosmic strings. There is you must have heard about cosmic strings. There's alternative theory of gravity that there are cosmic strings. These are usually one-dimensional objects, very long, which were originally produced in the universe. They can still survive till now, and they can produce observational effects, and this is how I'm looking for them. So these are just long parsecs long, not three-dimensional, not one-dimensional lines which have mass. So there is a paper which says that since they look just like DNA strands, they can be base of life instead of DNA. So life can be based on cosmic strings. I can share that paper with you if you're interested. You can share with students who like it. But unlike us, these particular life forms need a lot of energy, so they can live only inside the stars. They can't live outside the star. So how to detect, how to do, but who knows? But it is possible. It is possible. So there are something else was called desert varnish. There is you can also Google it. This effect, which is called desert varnish. There's desert, like desert, varnish. There's some change in colors on the stones. Some rocks change colors. Nobody knows for sure yet what is it, but it's not exactly bacteria, not exactly microorganisms that we understand. But somebody said that somebody detected that there is varnish on Mars. There was some change of color on some Martian rocks. So, and that is why there are papers even about that it is possible that desert varnish is something alive, but just not based on what we understand, our life, on DNA and so on. So, yes, that is one of the subjects of astrobiology. What is life? We don't know yet. We can't define it yet. Okay. Is there a distance learning course? PhD? No. PhD, you can't, in IA, you can't do PhD by distance. Masters, it might be possible, but PhD, no. It's not possible. At least not in institutes that I know. Okay. Can people contribute? Yes. Layman people. That's what exactly I'm talking about. It's called citizen science or citizen astronomy, because citizen science involves other subjects, biology, history, archaeology, and so on. But citizen astronomy, yes. And there are special programs even run, like, for example, Ananda Hota from Mumbai. He runs citizen science course, not course, program in radio astronomy. He even runs several workshops where people can come, students can come, learn what does it mean, and participate. You can even build small radio dish and put it on your roof and do a little bit of research in that. It's not very difficult, actually. So yes, you can check it out. Citizen astronomy. RAD at home. It is called RAD, R-A-D at home. RAD at home. Read at home. That is radio astronomy at home. Okay. Next question. If I want to work on astrobiology, yeah, that is very good. If it is possible. If any university can allow that, that is fantastic. It is possible. I just know that my daughter finished Christ University, BSc. She couldn't do that. She could do only biology, zoology, botany, like this, or physics, and there was no mix. But if some university allows that, that is good. Okay, but my name, Safonova. You're right, yeah, Safonova. I never thought about it. Fantastic. Okay, next question. Still my second year UG. Online internships. Online internship is a difficult question because there are all those courses on the internet. You can find many of them, but which actually give you something physical understanding, hand-on experience. You have to come to the institute in that sense. Citizen science, citizen astronomy, you can do online. You can learn how to analyze. You can even search for comets. Actually, can I share my screen again?
Yes, ma'am. You can share.
Yeah, just 1 second. I just can show this. One second. I just was talking about recently, and in that sense, I can. Show. Yeah. So, okay, let me share my screen. And yes, so about specifically comets are my love and hobby. So anyone can actually discover a comet. There is a Soho Observatory, which is hanging in L1, constantly observing the sun. And as I say here, in more than 25 years, found 5,000 comets. And a lot of citizen scientists actually did it. So how do they do it? They look at the movies like this, and they spot something that doesn't look like background star or something, as you can see, or some cosmic rays, as you can see here. And for example, this boy, Hanjitan, was working on it since he was 13 or something like this. He discovered more than 200 comets yet since he was 13 by just using this sun grazer project. So that is what actually possible to do. And there's a lot of citizen science. Galaxy Zoo, there is Galaxy Zoo, there is Universe, Zooniverse, so there are many things. Okay, I'll just stop because otherwise it will take too much time. It's a big program. But you can do this. You can search on the net and do this online. But this is not exactly internship, yeah? This is actual work. But to go into internship, you have to come to the institute and physically interact with the scientists, sit with them yourself. As I said, that shadow the scientist, it's actually students come to our institute and just hang out with our scientists all day. Okay, about panspermia question, reason for life. Well, panspermia is not a solution for our understanding how life originated, because it just moves the origin of life somewhere else. we still wouldn't understand how. That is why panspermia is possible. Like, for example, everybody knows that our Earth, when original was called Gaia, and then Theia, the planet, protoplanet, which was size of Mars roughly, hit our planet, yes? It melted and it created the moon. And the result is what we have Earth. So it is quite possible that Theia, which was unlike Earth, originated, now it is believed that there is a research, originated much farther outside. It had water. It had actually it brought water because Earth didn't have water. Earth was molten completely. And when Theia hit it, even whatever water could have created, it would have melted already. And Earth was formed much closer to the sun. So it is believed that Theia brought a lot of water to Earth. But it is quite possible that Theia could be already inhabited or habitable. Because it was formed further, it had water, it is quite possible that it brought life or origin of life to Earth. Because on molten Earth, nothing would have survived, could have survived. So that's what my latest idea is, like, what if Theia was inhabited even, not just habitable? Astrobiology internship, okay, that is, as I said, so there is that Amity University in Bombay, and they have astrobiology center, and they every year they organize astrobiology expedition. So this year I'm joining in Ladakh, and half of our participants will be actually students, not just researchers. So that will be a lot of, because Ladakh is analog of early Mars, current Ladakh, and we will be going to hot springs, to salt lakes, collect extremophiles samples. Extremophiles are those microorganisms which survive extreme environments. And we will be studying that. What is CGPA? I don't know what is CGPA. It's your marks. That is difficult to say. Well, but you know, in India, you have to go into PhD, you have to go through all the jest and all the exams that you can't avoid. And if you're in Calcutta, by the way, in Calcutta, there is a big center for which Sandeep Chakrabarty, you know Sandeep Manya, you know Sandeep Chakrabarty, you must have heard about him. He has a big center in Calcutta where they have a lot of, I have the so this is called Institute, Space, I think Space Institute, Space Science Institute. So here, yeah. Indian Center for Space Physics. Yeah, now it is called Indian Center for Space Physics. They have courses. They have even balloon course. They actually, last year I went there, they bought the land just outside Calcutta where they actually building the special launch pad. He launches balloons, big balloons, not weather balloons what we launch. He launches big, huge balloons that can actually lift a ton of equipment. And they have certificate courses and they have pre-PhD diploma, which is very useful. So they have all the certificate courses. I'll, if I can do it fast, which can be quite useful for students who joined now. So let me, I'm sorry, share my screen again. And you go here, Indian Center for Space Physics, and they have certificate courses. And they even have online classes for some, I guess. So they have this, and they have what is called pre-PhD diplomas. So this is pre-PhD diploma. So this is a very good initiative that he started. And they do develop a lot of things. And they do astrobiology, astrochemistry also. So this is actually a good resource. Yeah, you can go there. Okay. Next is evolutionary history. Well, I don't think so. What I think that environment can wipe out life. That's it. But what is great in the life organisms that we have on Earth is that they mutate. And mutation is actually the result of us existence of us as humans. Because you know that 70%, roughly 70% of our DNA are actually viral DNA. That's what mutation allows this. Mutation allows viruses infect us. We absorb their DNA, we change our DNA, and we use their DNA to mutate and to evolve. That was what evolution is. Okay. Yes, about cosmic strings, I will send to organizers. Okay, Manya, I will send to you. There are 2 papers, amazing papers. Yes, I will be happy to share. I've written a review. Okay. Oh, this is fantastic. Okay, I'll try. That sounds very nice. It sounds very interesting. Okay, no problem. I'll try. I'm not promising immediate response, but I'll try. Okay. Okay. So I hope I'm inspiring enough for you people to actually go and do astronomy. Why do we do astronomy? Actually, why do we do astronomy? Because we are human, yeah. What I'm actually writing an article on it, not the book, article about that. Astronomy is actually the oldest science. Astronomy shaped our minds, our brains, as we are now. Imagine ancient people just looking, roaming around, and they see that something is constantly going regularly in sky, and then that something goes away, it becomes dark. Then something comes, it becomes semi-light, like moon. Then it goes away again. So then they would notice the change of seasons also, that there is some seasons change, and we know that they noticed that calendar because calendars were found in the sky, this cave paintings. The sky, even images in cave paintings. There are some cave paintings where even constellations are drawn. So it means, and noticing the correlation, noticing the repetition, finding the correlation, and then using that correlation to predict. That is exactly what scientific method is. So we know that animals also know the difference between day and night. But unlike early humans, animals don't count. Early humans counted. They counted, they used it, and this is what science is. So astronomy is actually not only the first science ever engaged by humanity, but astronomy shaped our minds. And we humans, we want to know what is out there. It's not enough for us just to live on this planet. We want to understand what is this planet, why this planet, what is outside there, and how to go there. So astronomy in that sense is the best. Interns from BSc courses, yeah, I do have interns. I have a lot of data, and some students come to me from. I have Christ students doing masters, St. Joseph, and so on. Yes, I have a lot of data, and I need a lot of hands because I'm doing too many things at the same time. So and one problem with that is that things don't get completed. That is the problem because I'm getting too distracted. So I have a lot of data. If anyone can, I even welcome students who understand machine learning and artificial intelligence because that is what right now I need. I'll explain why. When I have a lot of data which I got with our telescope in Hanle. So that telescope just looks up and I take images of, let's say, globular cluster. I look for variability in globular cluster. And sometimes the weather is bad, sometimes the telescope shifts. So sometimes the stars are not round, but they're extended. They're elliptical, they're slightly shifted, the wind is strong. But it's the same star over the years. So can we actually improve the images? So one student from PES University here, he joined me for image improvement. We wrote actually already 2 papers on it. He now is doing PhD in America. He's also very smart in that sense. But the problem is that he made the codes, but he didn't make the software. So it's not the software where I can just upload the images and get the good images back. It's the codes which we have on saved, of course, and available. But these codes are not simply to use for as an application. So I need students who understand machine learning, optimization, not so much of AI, but machine learning, and Python programming and all to make is as a software. And this software can be used for many people. That software is actually quite good. Would be good because so many images are we just throw. Scientists just throw those images. But what to do? But sometimes you can't afford it when the third of images is spoiled. What to do? Your science suffer. Okay, universe missing its lithium. No, I don't think so. I don't think we're missing its lithium. That question is interested. I will check it out. The actual amount is much less. I don't know about it. I haven't heard about it. But we'll see. I'll check it out. Thank you for pointing it. Okay.
Yes, thank you so much, ma'am. For it was a very great session. We all learned a lot related to the how to get into the field of astronomy. Thank you so much for the session.
Yeah. So you please remind me to send me please the mail to remind what to send, what papers to send, what to share. I will be very happy to share. I can even share my citizen science presentation so that any kids who are interested, they can actually go and use that from Zooniverse and so on. I can even share that, my PPT.
Yes, ma'am. I will definitely mail you.
Just remind me.
Yes, ma'am.
Okay, thank you for your questions. I hope you would love astronomy. Just like I do.
Thanks so much.
Thank you so much, ma'am.
Thank you. Bye.